Hello everybody. So now you guys are going to be starting to take limits at infinity. Okay, so there's a couple things to watch out for. First is, there are these set of rules that you can go by. Um, I would rather you guys didn't use them. It's not that there's a problem with them. I just have a problem with or concern about just memorizing rules. So I'm going to show you a different way to do it. This is the approach that Delta Math is going to take. I'm going to try and avoid it because I think it doesn't lead to understanding, is I guess a way to say it. Before I can continue, you need to look at the concept of there's different sizes of infinity. And on its surface, you may be going, what do you mean, different sizes of infinity? Infinity compared to infinity plus 3. No. So here, you may think I'm contradicting myself. Infinity compared to infinity plus 3, that's the same. So if I gave you infinity over infinity plus 3, that's worth 1. Because infinity is so large. Adding 3 to it, no. That's just worth 1. I mean, these are the same size. I mean, you never know. If you had infinitely many dollars and somebody gave you $3, you would never notice it. Okay? You may think I'm being a little bit fuzzy with the math here. Well, let's just go $10. $10 is representing my infinity. $10 plus 3. Yeah, if infinity was $10, you would notice $13 versus $10. Okay, but let's go to 100. 100 plus 3. You notice it less. 1,000. 1,000 plus 3. You really aren't starting to notice it. $10,000 versus $10,000 and 3. $100,000 and $100,000 plus 3. Do you see how the larger this number gets, the less consequential adding something onto it is? Or, for that matter, subtracting something from it. Okay? So $1 million and $1 million plus 3. I mean, so just imagine infinity. Infinity is ginormously huge. You can ignore a number that's being added to this. And just think of it as infinity over infinity, which is worth 1. Okay, so that's when you're adding or subtracting something from it. So if I had infinity minus 2 over infinity, that's really just worth infinity over infinity, which is worth 1. Not trying to complicate it. If I had 2 times infinity, or 2 infinity minus 3 over just plain infinity, I can ignore this subtracting 3. 2 times infinity over infinity. This cancels out and leaves you just 2. Okay? Infinity minus 4 over 3 times infinity plus 6. Well, first off, the adding or subtracting of a number is inconsequential. You can ignore that. It just goes away. So I have infinity over 3 times infinity. This reduces, they cancel out, just like if it was a variable, and you're left with a third. Okay? So that's what it looks like. Well, I guess I could make it a little bit harder. 2 times infinity plus 5, 7 times infinity minus 4, so we're going to pull infinity. Adding or subtracting the number just goes away. This cancels out. So you have 2 sevens. Would be your answer. Now to ratchet it up, because we got to make it harder, okay, because that's just what this is going to do. All right, take a deep breath. You're going to be fine. Infinity versus infinity squared. Okay, this is where it gets to the different sizes of infinity. Let's go back to, say, 10 and 10 squared. So 10 versus 100. 100 versus 100 squared. So what's that, 10,000? you had $10 versus $10 squared, that's only 10 versus 100. Okay, yeah, you'd much rather have $100, without a doubt, than $10. But $100 compared to 10,000? Without a doubt, this is like, yeah, I'd much rather have the 10,000 versus 100. Let's go to 1,000 versus 1,000 squared. So what's that, 1,000 versus, isn't that 1,000,000? Do you see how much bigger that number squared is versus this number? So just imagine infinity versus infinity squared. This is infinitely times bigger. Let me write it this way. Infinity versus infinity times infinity. It's infinitely, there we go, infinitely times bigger than just plain old infinity. It's infinitely times bigger. So, if I had infinity squared plus infinity, think of it again as 1,000,000 and 1,000. Yeah, normally you'd say, yes, I'd like $1,000, please. But if you had $1,000,000, well, if you went up to Ho Chunk and lost $1,000, but you had 1,000,000, so what? You'd hardly notice that you lost $1,000. So if you're infinitely times bigger than this one, you really only care about this. Because this is so much bigger than that one. It's infinitely times bigger than this one. So this is inconsequential. It's like, for example, this that I just wrote a bit ago. That's infinitely huge. So what? You added 3 to it. You can just ignore it. This is infinitely times bigger than that. I can just ignore this. This would simplify down to, I can ignore that. We went through that just before I erased stuff. We got it. That's gone. This compared to that, you'd never notice. It's like, why even bother writing it? This compared to that. Well, think of it as infinity times infinity times infinity plus infinity times infinity. This and this are the same, but this one is that many times bigger than this one. So this can also go away, and you're left with infinity cubed. So what am I getting at? Here we go. If I want to take the limit, I do direct substitution. I get infinity plus 3 over infinity minus 2. These can go away, and you're left with infinity over infinity, which is worth 1. Okay? Do direct substitution. 7 times infinity minus 5 over 3 times infinity minus 2. These numbers on the end just go away. You have 7 times infinity over 3 times infinity. Think of these like a variable. They're not. They're an actual number. If you guys had this, wouldn't you cross out the x's and write 7/3? This is the same thing. The infinities cancel out. This is a product that's here. That size is the same as this size, so they cancel out and give you 7/3. Okay? But what about this? So I've got infinity squared plus 4 times infinity plus 3 over, infinity squared plus 2 times infinity, gosh, I'm looking at the upper equation, not the bottom one, minus 8. Well, you guys should be comfortable from this one back here that the 3 and the minus 8 just go away. So you're left with infinity squared plus 4 times infinity over infinity squared plus 2 times infinity. These compared to each other, this piece is infinitely times larger than that piece, even though that's 4 times infinity. This piece is also going to cancel out as compared to the size of this one. This is tiny compared to this, because this is infinitely times larger than 4 times infinity. Same deal here. So you're left with infinity squared over infinity squared, which is the same size top and bottom, so it's worth 1. Okay, fill them in. Infinity squared plus infinity minus 12 over 5 times infinity squared minus 2 times infinity minus 3. So we're comfortable at this point, should be, that these just cancel out. You should be comfortable that these, see, I'm hoping you're comfortable. I shouldn't say you should be. I'm hoping that you're comfortable that this piece compared to this piece, this is tiny. So I'm going to cancel this out. I'm not canceling it up and down. That's not what I'm doing. This piece compared to this piece is tiny, so I'm going to get rid of it. This piece compared to this piece is tiny, so I'm going to get rid of it. So at this point, I'm infinity squared over 5 times infinity squared. These pieces are the same size, so I'm going to cancel them out. But remember, there's a 1 upstairs, so your answer is 1/5. Okay. Here, so you've got 2 times infinity squared plus 4 times infinity minus 5 over 3 times infinity squared minus 1. So we've been saying just the plain old number is gone. This compared to this is tiny in size, so I'm going to get rid of it. It didn't, again, you're not canceling with something on the bottom, you're comparing this piece to that piece. Okay? So I'm left with 2 times infinity squared over 3 times infinity squared. These are the same size, they cancel out. So you're left with 2/3. That would be your limit. It's 2/3. Now let's grow to this one. Right? I got infinity cubed plus 2 times infinity squared plus 4 times infinity minus 5. I'm just doing direct substitution over 3 times infinity squared minus 1. So we've seen just a number cancels out. 4 times infinity compared to 2 times infinity squared is tiny. This is minuscule compared to this one. Now, we haven't seen cubes yet. Or, sorry, we did a bit ago. This square is tiny compared to this one for the same reason this one to that one. Infinity cubed is infinity times infinity times infinity. 2 times infinity times infinity. And this one is infinitely times larger than that one. So this also cancels out. The bottom, this cancels out. So what you're left with is infinity cubed over 3 times infinity squared. This reduces, just like if it was a variable. If you guys had x cubed over x squared, wouldn't that reduce to just x? Same thing. And I know there's a 3 on the bottom. I get that. I've got infinity over 3. Doesn't matter, you're dividing by 3. Infinity divided by 3 is still infinity. And I know you may be like, you're just making stuff up, Kestik. Nope, I'm not. Infinity divided by 3 is still infinity. That's like 2 times infinity is still infinity, isn't it? So infinity divided by 3 is still infinity. Okay? Infinity is not a limit. This one does not exist. Does not exist. That's what you'd write as your answer, D and E. Okay? Now, okay. Take these and fill them in. So you've got 2 times infinity squared plus 4 times infinity minus 5 over infinity cubed plus 3 times infinity squared minus 1. So as you've been seeing, these numbers just cancel out, not up and down, you're comparing them. 4 times infinity compared to 2 times infinity squared, gone. 3 times infinity squared compared to infinity cubed, this is gone. You're left with 2 times infinity squared over infinity cubed. This will reduce to 2 over infinity. What is 2 divided by a ginormously huge number worth? 0. If you've got an infinity left upstairs, you're going to get infinity, which is not a limit. It's not a maximum number. It's like a car. I mean, if your speed limit is infinity, that's not a limit. That's limitless. If you have infinity, how about infinity over 1? It does not exist because infinity can't be a limit. It isn't a limit. But this is 0. 2 over infinity. If you have an infinity left in the bottom, your limit is 0. If you have the infinity left over upstairs, then it does not exist. Okay? Filling it in. 2 infinity squared plus 4 times infinity minus 5 over infinity cubed minus 1. This compared to that is tiny. This compared to this is tiny. This compared to that one is tiny. So you have 2 infinity cubed over infinity cubed. Again, that's 2 over, whoops, I made a mistake, squared. Which again is 0. Okay. If you've got one like this, it's just infinity cubed minus 5 over 3 infinity squared minus 1, which is infinity cubed over 3 infinity squared, which is just infinity over 3, which is no limit, because this would reduce to just infinity, okay, which is no limit, dne. So dne is your answer. All right, so what are the ones in delta math going to look like? They're going to look like this, and they're going to have them all jumbled up in different orders. These just look like, they're just random order of the numbers. So what you're seeing is plain old numbers. So let me rephrase that. Plain old numbers go away. Cool, we got that. That is the biggest degree. Sorry, that is the degree. That's the biggest exponent. All the other stuff isn't going to count compared to these things. So you're left with negative 15 infinity to the 5th over 8 infinity to the 4th, which would reduce to negative 15 times infinity over 8, which would be infinity, or negative infinity in this case. So there's no limit, does not exist. Okay? So you're looking at the biggest degree. This compared to this is tiny. This compared to this is tiny. This compared to this is tiny. So you're left with 4, now do the substitution, infinity to the 4th over this, and this all cancel out. 3 x to the, infinity to the 4th. These are the same size, they're canceling out, so you're left with 4/3. Okay? Sorry that took a while to explain, I apologize, I really do try and keep these short, but you had to understand the idea of a different size of infinity. Otherwise, what you guys have to do is follow these rules. And I know that's just 3 rules, but I'd rather you understand what's going on rather than just doing the rule without knowing why you're doing it. Okay, thank you very much. Again, I'm sorry for the length.